Universal law of gravitation, suppose that we got two masses, M1, M2. Gravity comes from mass. When you have mass, you have gravity. So if I put two masses at a distance, separated at a distance, then this mass will attract this mass. And similarly, this mass will attract this mass. There will be two forces. This one will pull it, and this body will also pull this one towards it. How do I label the force of attraction? When you label the force of attraction, we first draw a line connecting the two bodies here, and then we draw the force. The force must be along the line. So this one, F, this force is applied by this one to bring it here. And this force is applied by this mass to pull it like this. So you got two. This is, we say, what force is this? Attraction, okay? Force of attraction. Forces of attraction. Now, Newton says this force of attraction is proportional to the product of the masses. What is product? Product is times, right? The product of M1, M2 means M1 times M2. Force is proportional to the product of the masses. This is what Newton says. And he also says that force is inversely proportional to the square of the separation. Here, R 是什么？ R 是它们的 separation distance, R. Square of the distance. Okay? That means 你的 distance 越大，你的 force 越小。然后你可以看到有 square 对吗？有 square 是说 for every increment of the distance, you put it the square. Okay, let's say the distance become twice. Then here become 1/4. So that means the force reduced by 4 times. Here. What we can see from here is for a small distance increment, the decrease in the force become very large. Okay, now this two is what is he says. If I combine these two, 我把这个两个 combine 起来，我可以讲 force 是 proportional to M1, M2 over R2, R square. Okay, now proportional, 如果我要把这个换去 equation, 我把这个换去等于，然后我要放一个 constant. 因为平时如果你讲 x proportional to y, 你的 graph 是怎样？你的 graph 是直线对吗 ？OK， 你这个直线它有 gradient 的。它可以是这样子，这样子，这样子，所以它的 gradient 是什么？那个是那个 constant， 意思说我可以把它写成 x 等于 ky， x y， the k represent the constant or the slope. Here, if I want to convert directly proportional to an equation, I can write it like this. I have to add a constant. Same here, 这个我要把它 convert 去 equation， 我就要把它，我要加一个 constant 等于 k m1 m2 除以 r2 like this. Now 这个 constant 他们选择加，他们选择一个 symbol 用 g, big G. Instead of writing k, they will use g. What does the G stands for? Okay, now before we talk about the G, again, 这个是什么 force? 这个是 gravitational force 对吗？这个就是这个了，这个和这个。Now, notice that the two objects have the same force is applied by the two objects. Here, if this is the Earth, and this is a mass, any mass, the Earth is pulling the mass towards the center. And the mass is also technically, it is also pulling the Earth towards it. Not only just the Earth is pulling, both the object is pulling each other. And the same magnitude of force is acting on the both body. How much the Earth pulls the mass is the same amount as how much the mass pulls the Earth. 这个 magnitude 是要一样的 for 这个两个。OK 啊 ？Now 这边我们看 G 是什么 ？G 我可以把它写成 OK, let's see. This one I bring here. R squared I bring here, M I bring here. So G equals to F times R squared over M1, M2. Okay, now here, look at the unit. This one is Newton. Here, this is distance, so M squared. This is kg. This is kg. So Newton, this is kg squared. Newton meter squared per kg squared. The unit you get N M squared per kg squared like this. What is this thing? This is gravitational constant. And Newton, he found that if you take two masses of 1 kg, let's say this is 1 kg, this is 1 kg. 你拿两个 1 kg 的东西，你把它放在1米的 separation, okay? Then the force of this, the magnitude of the force, equal to 6.67 times 10 power of minus 11 Newton. 这一个是当你用两个1 kg 放1米的。 他讲他的 force 会是这一个 value. Okay, if I put in the equation, this one equals to force times 1 over 1 times 1. Everything is 1. So you will find that G is equals to F. So what is gravitational constant? Gravitational constant 其实它就是 force 来的，只是它的 condition 就是当你 拿1 kg 放在1米的，它的 force 就是等于 gravitational constant， 也就是 6.67 乘10 power 减11，很小的 value 啊 ，minus 11 here， very small value. So we will use a constant G of 6.67 times 10 minus 11 Newton meter square kg 减2。 这个跟你讲什么？如果你有1 kg 的东西，把它放在1米的，它的 force 是这样子，这个是 constant 的意思。如果你有2 kg 的呢，或者如果你放它比较远呢，这样我们就要算了，我们就要算放进那个 constant 乘那个 mass 乘那个 r， 我们就找到它的 force 是多少。OK， 那这个我们叫 universal constant。universal， 什么是 universal? It can be applied anywhere. It can be applied to objects on the earth. It can be applied to planets in outer space, anywhere. So that becomes universal. Okay? Just like pi. Your pi is also universal, right? Pi equals to 3.142. What is pi? If you take the diameter, you take the circumference 2 pi r, you divide by the diameter. Here you get this value 3.142. Doesn't matter what circle. You can take a very small circle. You can take a very big circle. You will always get this. So it's always true. It is always true. So we say it is universal constant. It is always true. Okay. Right. Now, when Newton's formulated this one, 当他做这个东西的时候，他 assume 什么？他 assume that these two masses This mass and this mass, they are point masses. Point mass. 意思说就是一个点罢了。为什么它 assume point mass？ 这个 derivation 啊，这个 formula， 这个 mass 是 based on point masses。意思说我们会 make assumption that all masses that we are calculating, they are point masses like this. Why? Because Newton at that time he wasn't sure. He wasn't sure whether this can be applied for the big body that are placed very close to each other. For example, like you have big body here, one planet and then another planet like this, placed very close to each other. He wasn't sure whether this can be applied or not. So he made an assumption that this only apply for point masses. Okay, point masses like this. So if the question asks, then you know how to answer. What is assumption we make? Point masses. So if the assumption is point masses, that means this equation is still at the basic, a very basic law. A very basic law, because there is a limitation. It can be only applied to point masses. But in reality, we don't have that much point masses. It's all distributed, right? So this is just a basic law. This is a fundamental law of gravitation. Okay, now we talk about this force. 这个是 force of attraction, 也就是 gravitational force. So gravitational force, 现在你知道它不只是一个 pull 罢了啊，它是双方都有的。Okay, now 这个 force 三个 property that you need to remember. First is that this is a force that is attraction only. Attraction only. Number one. Number two, that it is regardless of medium. 意思说，不管它们之间的 medium 是什么，可以是水，可以是 vacuum， 可以是 air， 它的 force 都是一样的，都是会有 regardless of medium. Number three, this force is a long range. It can act very, very far. The sun and the 8 planets. This one can stretch very far. So it is a long range force. Okay, now, so theoretically, any masses can attract. You and your friend stand next to each other. Here. You stand here, your friend stand here. You stand at a distance 1 meter. And let's say you are 60 kg, your friend 50 kg. What is the force of attraction? Okay, very simple. We calculate using F equals to constant 6.67 times minus 11. Product of the masses, so 60. Mixture in SI unit, 60 into 50. And then divided by R squared. R 1 meter squared here equals to, okay, we calculate this, we will get a very small value, 2 times 10 minus of 7 Newton. This force is very small, that we will say it is negligible. Okay, negligible, what does it mean? That means it is too small that we do not count it. 太小了，没有分别，所以我直接 drop 掉它。Okay, 我直接当它没有在。This is negligible, this force. Now, this is the force of attraction between two persons, right? But we don't feel it. Maybe you feel it because sometimes you may have experienced, sometimes you sit here and then you feel like somebody is looking at you, or you are looking at somebody. So maybe it's this one. I don't know. We don't know, right? It could be. Now, here, the force of attraction, if you compare to the Earth, if you compare to the Earth, here, this is the Earth, and here are the objects on the Earth. These two objects, they attract, right? They attract, and this force is very small compared to the Earth and the object. The Earth and the object also attract like this. Right? So, any forces of attraction between objects on the Earth, when compared to the Earth, is like nothing. So, we just drop all the forces of attraction. We do not look at all this. It is negligible, right? So, we only look at the force of attraction between object and the Earth. This value, this force, is not negligible because the mass of the Earth is very huge, that this becomes very significant. And this is what gives us our gravity. Okay, now, here's one question. 刚刚我讲同样的 force act 在两个 body 对吗？可是为什么当你 drop 那个 object fall towards the earth, but not the earth fall towards the object like this? Since the same force is acting. Let's say I take a pen like this. The same force is acting, pulling downward and pulling the earth up. But how come the pen fall, but the earth doesn't fall up like that? This is because of the mass. You have learned F equals to ma. F equals to ma. For the same force, okay, 这个是 constant. 这个是 constant, 我把 A 搬过来 F over A equals to m. 如果这个是 constant, acceleration, mass down, acceleration very small. The reason why the earth doesn't fall up is because the mass is too high, the acceleration is barely noticeable. You cannot see the acceleration, but theoretically, the earth is also accelerating towards the pen. But because the mass of this is a lot smaller, so you see this effect of moving towards, but you do not see the effect of the earth. The acceleration is too small. Okay, now here let me get some space first. Okay, let's see. Here I draw, this is the earth, and I place an object here, mass m1. Let's take the mass of the earth. Okay, we take this as m1, this is m2. Two body, so they have force of attraction, down, up. Okay, now this force, let's just look at this force. 我们只是看这个 force 罢了，我们把其他的 force 当作没有在，就是你讲 air resistance 啊，其他那种 force 不在啊，单单这个 gravity force 罢了。So 这个 force 是变成 resultant， 对吗？因为 no other forces, so this is my resultant force, my net force. Okay, when this force becomes the net force, I can use F equals to ma. F equals to ma. M 是这个 mass m, 所以 m2a. Can see or not? This one I write it here. The bright spot is blocking you. M2a. Okay? Force acting on this one. Now, based on Newton's law of gravitation, we also know that the same F, okay, the same F is G m1 m2 over r squared, right? So that means I can make this one the same as this one, G m1 m2 over r2 等于 m2a. Okay, cancel this and this. I get G m1 over r squared a. What is this acceleration? This acceleration is the acceleration of the object here, a. right? The same A here. This acceleration is G times M1. Whose mass is this? 谁的 mass? 这个是 Earth 的 mass. And R, that is the distance between them, right? Now, here's a question. What is the R? The distance between them. You see, the radius of the Earth is very large. What is the radius of the Earth? That is about 6,400 kilometers. That is only the radius. Let me write R here. 6,400 km, the radius of the Earth. Let's say I place the mass at 10 km. 10 km from the ground. Is it high? It's very high, right? 10 km from the ground. But if you compare this distance, 10 km compared with the 6,400, is it going to make any difference? You place at 10 km compared to this very large, at most you get 6,410 kilometers. When you put in the equation, you will get the same value. That means this small distance is not significant at all compared to my Earth radius. That means I will assume that this object, I will take the distance here, the same as the radius of the Earth, 6,400. Instead of taking this one, I say no. This one, no. I will take this one. Because the 10 km is too small already. It's too small, it doesn't make any difference. So I will take this one. Okay, so if I take this one, then this distance R between them, I will write as the radius of the Earth R, like this. Okay, 大 R 这个是 radius of the Earth。这里的 distance 我不用理，因为太小了。就算你这个是50 km、100 km， 它还是很小。就算它是100 km， 它 compare 跟这个6400，最多到6500不了。当你 square 的时候，你拿到的分别也是看不到的。OK 啊，到几时有到几高，我们才开始拿那个height。我们是讲着到几千 kilometer， 好像 satellite 2000 kilometers。Then this height from the surface become comparable with 6,400. Then in that case, we cannot ignore the 2,000. We have to put it here. Okay, so that means if I put my object up here at 2,000, like the satellite is even higher. 20,000 also got 20,000 kilometers. That is the height of the geostationary. All right, geostationary satellite. So let's just say 2,000 kilometers. Okay, so 2,000 is 2,000 哪里 2,000 from the ground, from the ground, not the center of the Earth. So in this case, this one I will write like this: acceleration 等于 gm1 over 这个 r 就是变成 radius of Earth 再加你的 altitude h square。这个是什么？这个是 distance from ground。Okay. Radius 加 distance. So you take this one. For this one, we take this one. Okay. Now here we got two formulas, right? This one we use it when object at significant altitude. At significant h, very large h. Here I will use this at the surface of the Earth. So any calculation done on the surface, I will use this one. Close to the ground. When I say surface, it can be any distance from 0 to 10 km, a few 10 to 100 km. This is the meaning of at surface, okay? Not exactly on the surface. It can be as high as 10 km. That is also at surface. 可以吗 ？OK 啊 ，Now 这个两个是 acceleration 对吗？这个是 acceleration 什么？因为我们的 gravitational force yang create 我们的 acceleration. The acceleration is from the gravitational force. So we will call this acceleration due to gravity, right? Acceleration due to gravity. You have seen this, you are familiar with this already. What is the value of this one? Acceleration due to gravity is the G, right? The normal calculation that you do for the G, 9.81 meter per second square. This is acceleration due to gravity. 9.81 is the acceleration at the surface. 我们做 calculation 的时候，我们是用这个是固定了的，对吗？没有弯的，一直用9.81或者10，因为全部的 calculation 都是在 surface。可是如果你在讲着很高的东西 satellite。You are calculating the acceleration of satellite. You cannot use this one. No. You will have a new value. This one. Gm over r plus h. Here. Okay. Now, which one is greater? Here and here. This is at surface. This is at height. 这个都是 constant 来的吗？ G 跟 M constant， 同样的地球 radius 也是 constant， 这个加了一个 h， 意思说这个的分母比较大，意思说你的 acceleration 比较小。This acceleration is less than this acceleration because here plus h, this one bigger, this one smaller. Okay, so here I will call this gravitational acceleration G at a certain height, GH, will be less than the gravitational acceleration at the surface. Surface is 9.8, right? 9.81. Here, at any altitude going up, will be less than 9.1. So 你这里上2000、3000、4000，你的这个9.81会做什么？这个9.81会 decrease， 9876 decrease。OK， 因为如果你 logically 这样子想，你的 force 越远就越弱吗？所以你的 G 也是越小哦，你的 G 也是越小。Okay, now what you need to remember, these two formula, this one. Why we need to know this one? Why we need to know the G? The G, is it important? Of course, yes. How is that applied to our life? The gravitational acceleration affect cell growth. We human, for our cell to grow, we need to be in a suitable condition. If you are on other planet where the gravitational field is weaker, it affects the cell growth. Okay, all of that. It affects the blood flow, all that. Because the G is the one that affects the weight. F equals to mg. If the G is half, if this is half, then your weight also half. If you weigh 600 Newton, then your weight becomes 300 Newton. Now, your weight decreased by half, that affects the blood circulation, the cell growth, everything. All right? That is why the G is important in our daily life. Okay. Example, what is the gravitational acceleration acting on the satellite that is at 20,000 kilometer height? Is this height significant? This is altitude, right? 这个给你的是 measured from ground 啊，不是 from the center of the earth, it's from the ground. So this height is very significant. So we will use, okay, when we calculate, we will use this G equals to GM over R plus H squared. Okay, so 6.67 times. What is the mass of the Earth? Okay, the mass of the Earth will be given to you. Okay, it will be given to you 6 times 10 power 24 in kg. In kg. Now, over radius is 6,400. You want to be careful this one. A lot of students, when they put here, they forgot to convert this one. So 6,400 times 1,000 into meter plus, you have this one also, right? So, okay, we'll convert together like this. 6,400 plus 2,200 like this times 1,000. Okay, change into meter, and then don't forget you have a square here. I have to square this. Okay, now you can calculate. When you calculate, because you are dealing with very large numbers, so that means when you calculate, you want to take all the decimal. Okay, take as many decimal as you can. 0.447, 0.57. ms minus 2. Is it so small? Yes. Okay. So at that height, 0.57. At the surface, how much? 9. Okay, now let me clear this. How you do this? Two asteroids exerts gravitational force on one another. By what factor would this force change if one asteroid double in mass, the other asteroid triple in mass, and the distance between them is quadruple times 4? OK， 他讲这如果一来我有两个 asteroid M1 M2， 你的 force of attraction F， 如果其中一个 mass 它的 mass double， 然后另外一个它的 mass triple， 然后它的 distance 乘4，这样它会有什么影响在我的 force？ We want to find that. Okay, very simple. Now, what is the formula we use? Force, right? Force, there's only 3 formula we learn, right? So this one must be the force GMM over R squared. Okay, so let's say this is this one, force. The initial force when the mass is M1, M2. Now, and then it says one mass is double. Okay, let new force be F dash. Okay, the force that has changed, the new one. So F dash equals to what? Equals to GM1 dash M2 dash. 这种都是新的 mass 吗？ R2 R square dash. OK， 这个是这个 force， 然后这个 force 是当我一个 triple 一个 double 这样子，所以我用另外一个 symbol F dash equals to GM1 M2 R. Now it says 1 is double, so we can change this one to G2 M1. Double this one. The other one is triple times into 3 M2. Doesn't matter which one double, which one triple. When at the end, you'll still get the same thing because we are calculating the factor. Okay, if this one is double, this one is triple, again, you bring out, you will also get 6G and 1 and 2. Okay, now the distance also quadruple, right? Quadruple 就是说你的 distance 也是四倍， so 4R square. Okay, again, here we have a square here, so we put 4R, 4 times of it, R square. All right, so this one, we put it like this, 6G M1, M2. Okay, here, 16R squared, 16R squared. Okay, so this one, then I bring this one out here, 3, 8. 2816 236 3 over 8 OK 我这边写3 over 8 G M1 M2 R2 把它拿出来，这个是 F dash 了，对吗？ F dash 等于3 over 8 G M1 M2 like this。 那你的这个是什么？你的这个就是你的 original F。 So you put in, then you get F new force equals to 3 over A of F. This is your answer. Okay, 3 minutes, and we go to the one more part. The next part. Okay, I will erase this. Okay, bye. So we have so far talked about forces, gravitational force. Now you get a more in-depth understanding on the gravitational force. Let's say we have a satellite orbiting the Earth. Here. Force of attraction, this one pulling this one pulling this. Okay, now here's a question. How come the satellite can stay up there without moving towards the Earth like this? Let me change this because you cannot see here. F. We observe that the gravity is pulling the satellite, but the satellite moves in a circular path. Instead of falling towards the Earth, the satellite moves in a circular path. How come? Why wouldn't the satellite just fall towards the Earth like this? Now, you see. Imagine if I stand at the tip of the mountain. I stand here, and then I throw an object. I throw an object like this. When I throw the object, I'm giving it a horizontal velocity. This velocity, we call it linear velocity, because when I throw it, it moves in a straight line like this. It moves in a linear path. So I will call it a linear velocity, like this, v. Okay, now, what happens as soon as I throw it? The object will fall down like this. I throw it, fall down like that. So that means this one will come, the moment it leaves my hand, it will come down like this. This is the trajectory, right? This is the path. Now, this time I throw with a greater force. I throw like this. Then this one go further, also come back down. What happens if I keep trying and trying, and I keep throwing with a greater and greater force, and at one point, you will see this happen. This one go so large, V, that it starts to fall around the Earth like this. Like this, it falls around the Earth, here, and then come back. When it comes back to the same location, I duck, and then the object goes through. Continue like this. What we get here? We get a circular motion. We get an orbit. What have I done here at first? I give it linear velocity. Linear v. This linear v is very large, that it can go around the Earth without falling towards the Earth. How is this possible? Okay, let's see. What is the physics behind this? Okay, we move it to here. Now, this satellite is like the object I throw. The satellite is moving with a linear velocity. By nature, every object, they move in a straight line. So this satellite is moving like this. Okay, now, here, when the satellite come here, because the velocity vector is in this direction, right? So the satellite wants to come here. When the satellite come here, go like this. At this point, the gravitational from the Earth will pull it. The force is here. I draw from the center, join here. This is the force, like this. The gravitational force pull it towards here. So instead of the satellite coming in this direction, now the satellite come here. OK， 它本来想这样子走，过后这个 force 它讲 no， you have to come here. Then it come here. Very tiny movement, very small movement. Now it has come here. That means His new velocity from here is like this. Again, linear velocity. Okay, so the same thing happened from here. The satellite wants to come here. As it reaches this point, then again you have this force pull it like this. This is the gravity. Okay, so it has come here, then the satellite comes like this. What you see here, the velocity vector keeps changing because of the gravity from the Earth. Here, here, here. 你这里看到的就是 satellite， 每当它要 escape， 它要走出来的时候 ，gravity 不给它走 ，gravity 给它进回来。每当它要走开 ，gravity 拉进来；每当它要走开 ，gravity 拉进来。So as a result, what do you get? As a result, you get a circular motion. Okay, you get a what? Circular motion. So here, the satellite always tries to get away. Satellite always tries to come out. But the Earth always tries to pull it. Satellite always tries to come out, Earth always tries to pull it. From there, they find a balance. Balance. And the balance, the effect, what is the effect that we see when it is balanced? The effect is circular motion. Please understand this, right? Balance, effect, what do we see as a result? Circular motion because of this thing, these two things. Here and here. Like this. 所以为什么月亮永远都不会跌去地球？为什么 satellite 永远都不会跌去地球？因为它们本身也是有 speed， 它们的这个 speed 是很大。This is very large value that keep it from falling down. It is a very large enough to keep it from falling down, but small enough to prevent it from drifting away. All right? Now, when we have force, we have acceleration. F equals to ma. 当我们有 force， 我们就有 acceleration。然后 force 跟 acceleration 的 direction 是一样。意思说，这个 force 叫它来，这个 force 叫它来，你也是有 acceleration， 因为这个 force 啊，所以你有 acceleration。这个 acceleration 是指向哪里？很重要啊 ！acceleration 指向哪里 ？acceleration 指向地球的中心，跟这个 force 一样。这里 acceleration 指向哪里 ？Towards the earth. Here, acceleration towards the earth. The acceleration is pointing towards the earth, same as the force, but the velocity vector is like this. Okay? This acceleration, we give it a name. What do we call this name? Because this acceleration is the acceleration that keep it in circular motion. Okay? It is the force that create the acceleration to keep it in circular motion. So this, we call it centripetal. Centripetal acceleration. Okay, centripetal acceleration. Now, the force that create this one, the F, this one, we call this centripetal force. Centripetal force. And centripetal acceleration. So, why should object move in circular motion? Because of centripetal force and centripetal acceleration. 一样的 force 跟 acceleration ma. OK， 在这个情况，什么是我的 centripetal force？ Gravity 就是我的 centripetal force。 here. The gravity is my centripetal force. This force, right? Okay, now, so here we will write down the centripetal force. Centripetal force is expressed at F 等于 ma 啊，对吗 ？ma 啊 ，so 这个是 centripetal force ma， 这个是 centripetal acceleration， 所以我可以把它写成 m a， 它变成 v square over r。centripetal acceleration 的 formula 也就是 v square over r。Why 啊 ？Why this one 啊 ？Why acceleration is v square over r? Okay, this can be proven mathematically, but this will be discussed in other lesson, because here the derivation of this one is actually a long process. Okay, because here today we are focusing on the gravitational, so I don't want to talk about this today. But for now, let's just hold on to the idea that the centripetal acceleration is v squared over r. Put it here, you get mv squared over r. Okay, so because this is not our main topic today, so I will leave it for the next lesson. So centripetal force mv squared over r. Here, F mv squared over r. Whose m is this? Whose m is this? This m is the m of the satellite, the object that is orbiting. Okay, here, object, orbiting object. What is the v? This is the linear speed, the linear velocity. That is the speed of the satellite, the speed of satellite that's moving. What is the r? R is the distance, the radius of orbit. Okay, now let's stop here. Knowing the mass, linear speed, and r, we can find the centripetal force. This force, the centripetal force, is also gravitational, right? 它就是 gravitational force， 意思说，你可以用 gmm over r square， 或者你可以用这一个。OK 啊，来多一次 F， 刚刚我们的 formula gmm m1 m2 over r square， 这个是单单两个 object m1 m2 的 force of attraction， 我们可以算到这一个 F 等于 mv square over r， 这个是 for 一个 object， 然后另外一个 orbiting around it。 This is for circular motion, but we are also finding the same force F here. F。 你这个跟这个也是一样的东西，只是这个它是 orbiting, but the forces here is gravity. This is also gravity. I can calculate using either one, depending on what the question gives me. Basically, this is the same as this one. Okay, now, 所以他们怎样把它拿下来？ You have seen when the satellite reaches the lifespan, then it will fall down to the earth. That is when the speed reduces. One way you can bring the satellite down is by reducing the speed, because the speed is the one that keeps it up there. When the speed reduces, then this one will come down. How does it come down? The satellite will go spiral in like this. Here is the Earth, right? And then the satellite will go like this, spiraling down like this. Okay, this trajectory it will take. This is when the satellite is losing speed. Losing what speed? Losing linear speed. Losing linear velocity. 就很像这一个 losing linear velocity。所以你要 crash 一个 satellite， 你只需要 decrease 它的 velocity。Okay, if you want to crash the satellite, you just decrease the velocity, then it comes down. Okay, so another way to think of the linear velocity is 就很像你把一个 string 你绑着一个 pendulum and then you rotate the pendulum like this. Right? You rotate the pendulum like this. What happens when the string suddenly breaks? Here, when the pendulum comes to this direction, and then suddenly the string breaks. What happened to this pendulum? This pendulum will continue to go in whichever direction it is facing, this direction. It will launch from here. If this break, then it go like this. If the pendulum has come to here, and then the string breaks, then the pendulum will go like this. This is your V, this is your V. This is the linear velocity. So during circular motion, what is the linear velocity direction? It is always, we say, tangent to the circular motion, tangent to the circle, like this. Okay, this velocity is tangent to the that is the direction of the velocity. Where is the direction of acceleration? Centripetal acceleration to the center. To the center, that's acceleration. 可能你问 ，OK， 为什么它有 acceleration， 它不去中间？把它从另外一个角度想，你不要问为什么有 acceleration， 它不会去中间。Instead， 你这样子问，就是因为这个 acceleration 它走圆圈。如果不是这个 acceleration， 它就会出来，就是因为这个 acceleration 它走圆圈。OK， that's why it continues to go like this. Right. Last thing, v 跟 velocity 跟 speed 一样吗？一个是 vector， 一个是 scalar。velocity 是有 direction 的，所以如果 question 问你 ，what happened to the velocity? Is it constant or is it not constant? Can the velocity be constant? Cannot, because this velocity is pointing in this direction. The next second, the direction has changed. So velocity is a vector, direction has changed. It is not constant, but the speed is constant. Here, how fast the satellite is moving is the same as how fast it is moving here. We are talking about the magnitude is the same at any point. So for a circular motion, I will write speed is constant. Speed is constant. Velocity is not constant. Why? Because of direction changing. OK，我会 send 那个exercise。Okay, let me share my screen first. Okay, like we try out these exercises 54 until 57. The answers is at the end of the question. Okay, we look at question 56. Here we got three masses and they are situated along the same line. So if I draw a line joining the center like this, what is the net gravitational force on planet Z? OK， 因为我们这边有三个 body 啊 ，Let's say 我们只是看 x 跟 z， 如果 x 跟 z 哦，它们两个有 force of attraction 对吗？ Now 那个 force 呢 is acting on the same along the line, right? Along the line, so like this. This force, let's call it Fxz. OK， Now 然后我们也有 mass y。mass y 现在我们看 y 跟 z 啊。Y 跟 Z 它们也是有 force of attraction like this one and then we have another one like this 这个 force 是 FYZ 意思是说你有两个 force of attraction acting on the planet Z and the two forces they are on the same line along the same line in the same direction. Then to find the net gravitational force, you can add up these two forces. So that means first you have to find the Fxz, okay, the force between x and z. And then second, you have to find also the force yz. Then you add up these two. You will get the resultant force. Okay, so you can do like Fxz, G, mz, mx r squared.
OK，我们可以看我刚刚 send 的那个第二个分 worksheet，只是做1、4、8、10还有14啊。So 我们先看第一题。Figure 1 shows 3 uniform masses in a row. The force on the 1 kg is 0. Calculate x, the distance between the 1 kg mass and the 4 kg mass. OK， 他讲 the force on the 1 kg is 0。我们先看1 kg 有多少个 force acting 啊 So between 9 kg 跟1 kg， 我们有 gravitational force like this. Let's call this as F12. Okay, we call the 9 kg as our mass 1, M1, M2, now M sun. So this force is F12. Now, and then M2 and M3, 它们也是有 force of attraction. So this is F2 sun. Now, 它讲 force on the 1 kg is 0， 意思说 F12 是等于 F2 sun balance. F12 equals to F23. F12 is G M1 M2 over R12 squared equals to F23 G M2 M3 over R23 squared. Okay, we cancel this. And then we get M1, M2, and M2, M3. Yeah? So M1, M2 is 9 into 1, 9 into 1. And then R12 is, we take 15 minus x squared. Equals M2, M3. Okay, 1 times 4 over x squared. Then you just solve this. So we get 9 over 15 minus x squared. 4 over x squared. Okay, cross multiply, we get 9x squared equals to 4, 15 minus x squared. And I take the square root of both sides. I get 3x equals to 2, 15 minus x. -30 2x and 5x equals to 30. So x is 6. Okay, 6 meter. Okay, question 4. We look at one more question. The gravitational force on a mass of 1 kg at the Earth's surface is 10. Assuming the Earth is a sphere of radius r, calculate the gravitational force on a satellite of mass 100 kg in a circular orbit of radius 2r. Okay, that means on the Earth, at the Earth's surface, if you have a mass of 1 kg, the force is 10 Newton, right? And then it says, calculate the gravitational force on a satellite of mass 100 kg. So satellite is up here. If this is 100 kg, and what is altitude? Altitude is 2r. Now the 2r is measured from the center of the Earth. 2r, so that is not the altitude. 2r is actually, because altitude is just measured to the surface of the Earth. The 2r is measured to the center. R. This is 2r. That means twice the radius lah. Okay, twice the radius. Okay, you want to get the force. So I will write, first we have the formula F equals gmm. One is mass of the Earth, this is mass of the object, over r squared. Now we can drop the constant, we can do like this. The g is a constant, it doesn't change, right? For these two objects, for the 1 kg object or the 100 kg satellite is the same g, right? They have the same g, and then they are also on the same planet, ME. So these two are constants. So if these two are constant, then I can drop it. I can write F is proportional to mr squared. Okay. Now I will write here for the 1 kg mass at surface. Surface, that means at the radius r. F equals to m over r squared. 10 equals to 1 kg over big R squared. This is my equation 1. Okay, then I will create one more for 100 kg satellite at 2R. We use the same equation, F equals to mr squared. So I'm going to use a new symbol F dash, because this is the one I want to find, right? The force acting on this thing. It cannot be the same as this one. So F dash equals to, the mass is 100 over 2R and then square. Okay, so this one is equals to 100 over 4R squared, or 25 over R squared. 414, 25. Okay, this is my equation 2. Okay, from 2, F dash equals to 25 times 1 over R squared. Sub 1 into 2, so we get 250. OK，我们先到这边，然后我们下个拜二继续。